Hello everyone. My name is Akanksha Agarwala and this is Team 2 Deliverable 7 presentation for our project called Squander. For our agenda today, I will be discussing the details of our team members. We will be giving you a project overview followed by personas. Then we will be discussing about the technologies used along with the design architecture of the Squander application. Then we will be giving you a sprint overview walkthrough along with the product backlog and spring backlog. Then we will be discussing the retrospective. Then we will be discussing about the future sprint. And then we will be giving the project demo. So my team consists of five individuals who are amazing. So as you know, our cloud engineer is Austin Blees, who has contributed to the architecture of the project where he has integrated different features and services and has created the application as an infrastructure as code. Then is our machine learning engineer Nicholas Wong, whose responsibilities was to design a computer vision model architecture where he has trained and evaluated the model performance by gathering different image data for training. Then is our iOS developer Rajat Nagavkar, who is responsible for designing and development of the Squander application. He has integrated the machine learning model to provide specific results and also have tested the application to provide a better user experience. Then is our full stack developer and quality analyst Suryadeep Nalana, who also has contributed to the design and development of the application along with Rajat Nagavkar. He has authored technical document of the project and he has been continuously testing our application Squander to make sure that the app is user friendly. Then here am I, Akanksha Agarwala, who is the project manager and the scrum master, and my responsibilities was to lead the team meeting and keep the team on task. I was responsible to maintain the project's GitHub repository and wiki. I was also responsible for documenting the test cases and co-authored technical paper along with Suryadeep Nalana.
Project overview. Problem statement. With the vast population of people around the world, the amount of waste produced has been gradually increasing with the increase in population. On an average, the world produces 2 billion tons of urban solid waste yearly, and United States being the highest producers of waste among others. Around the world, the waste that is produced remains unprocessed due to lack of recycling knowledge with the people. Our scanner app overcomes this problem by producing a complete solution to organize and plan the disposal of waste through image recognition technology using machine learning algorithm to detect recyclable waste from images and produce proper disposable. With our app, we make people be responsible and contribute to make this world a better place. Project description. Our Squander application is an image-based waste detection mobile application. It is worked by a user submits an image to the application and a trained machine learning model runs on the image and gives results and information. The application is a simple tool to detect waste with best accuracy results and easy steps to undergo the process in the application. And one more thing, why you should use the application is it because it produces nearest recycling location along the rates and option to schedule a pickup personas. Zil, uh, Zil is a 32-year-old. He's an event organizer. Uh, he has organized many big parties. He takes all the responsibilities, such as handling the decorations of the event and catering the food. His company particularly known for the food that is served to the people with tasty and hygienic food. After the party ends, the food that is left should be trashed carefully, and Sil is responsible to it. Sil can do easily with Squander application by taking the image of this his trash and finding all the information of what kind of waste that can be trashed, that is found within his image, and where he can take this trash to dump and schedule a pickup of his trash from nearest recycling factory location on the application. Simon. Simon is a mechanic. His age is of 35 years. He inspects the vehicles like cars, motorbicycle, light trucks that comes to his garage for a repair. His work produces a lot of metallic waste in a day that comes from repairing the vehicles, and his metallic waste can be taken by recycling companies, and Simon can make money out of it. He can contact the recycling company and have a deal using Squander app. David. David has retired from his sales executive job recently. After producing more than 30 years of his service, he was successful in his field and has been an inspiration for others. After the retirement, he wanted to get his house renovated. Now he is passing his time by involving in the construction work with something he can do. With Squander app, David can participate in cleaning the construction waste from his site that can be detect the waste material and find recycling company location to trash the waste, keeping the environmental at a better place. Minimal viable product. The features are the map integration with nearby recycling factory location, scheduling the pickup of recycling waste by the factory, creation of user profile for each user uses the application, and showing the history of a pickup that is scheduled by a user, and finally showing the recycling statistics for an each user.
Hey guys, welcome to the technology sections in Squander. We have the machine learning API Keras, and for the backend we have Python, and we also have Google Maps integrations to find the locations of uh, recycling locations. I'm sorry, I think I'm hiding the TensorFlow, but TensorFlow is also a machine learning library that we use with Keras. Um, so we have the backend machine learning application that identifies recyclables from the pixel running with the TensorFlow framework. For the orchestration and deployment, we have CloudFormation. CloudFormation uses Cloud Development Kit uses CloudFormation to deploy the whole infrastructure in AWS. We also have the iOS Development Kit, the Swift, and the CoreML. So CoreML provides us inbuilt machine learning capabilities in iPhone and Apple-based devices. For the architectural design, we have the sequence diagram. So in the first phase, we have the user opening the Squander app, and then they take a picture of the garbage and uploads it. The uploaded request is handled by the request controller, which in turn passes the request and the image to the machine learning. And you would see that the data that's sent has a processed image over a raw image. That's because the machine learning takes in a specific format of the image, and we have the request handler managing the input to the machine learning in a specific format, and ensures that any image that's taken would comply with the standards of machine learning architecture that's designed to identify the images, and hence we also have a quality control at that point. The machine learning application, the machine learning model identifies the recyclables. That's what you see in this action here, and that data is passed to the backend, which in turn formats the information from the machine learning model and compiles it to a specific format that's consumed by the Google Maps API. And we also provide uh, both the output from the machine learning model and the processed backend information, and also the Google Maps result to the mobile application. As for the architecture, which would provide a higher view of how things are working in the backend, we have the IAM uh, authentication to allow only authorized users to access any of these informations or any of the dependencies the app is running on. The code deploy ensures code deploy works with the code cloud formation and ensures the resources are deployed and are connected with each other. We also have the backend machine learning model and the machine learning model using the S3. Um, so as I mentioned before, the request handler processes the image and it uses S3 to store the image, and the stored image is consumed by the machine learning model. And then we have the Amazon Cloud Watch consuming all the request queries and other information that's highly required for debugging purposes. And also it complies with the standards of AWS. Um, we also have the MVC view for the application. The app is designed specifically to respond based on how the user is interacting with it. So the MVC architecture has proven to be the most um, agile in that specific front. So we have the users using the mobile application, and based on the activities of the user on the application, we have multiple requests passing through each of those modules. Thank you.
Thanks, Austin. Next, I'll be talking about our machine learning algorithm. The way this works is our algorithm takes an image and splits it up into pixels. Then it sends the pixels to the input layer of our model. Then that layer gets put through a series of hidden layers where calculations occur. Then we get to the output layer where we see confidence values produced from our model. These confidence values tell us what our image got classified as. In this case, it would be plastic. Now, onto the model classification. Our model is able to classify our images into 6 classes: cardboard, glass, metal, paper, plastic, and miscellaneous trash. And on the right, we can see a bunch of images that were used when training the model. Now, to talk more about the model training, these are the initial results of evaluating our model. As you can see, the evaluation results were okay, with the accuracy being about 75%. But we can see on the left that when the image is clear and visible, the model is very sure about what the image is classifying as. In this case, it is a glass bottle, and the model is 100% certain that it is glass. To alleviate some of the need for more data, we implement transfer learning into our model. By doing this, we can leverage a pre-trained model that is trained on a very large data set and use some of that training to improve the performance of our model without having to go out and get our own large volume of data. Then we can fine-tune that model to fit our needs. Now I will be talking about the sprint overview. As we can see from our Sprint 6 burndown chart, we were able to perform tasks in a pretty timely manner, and we were able to complete most of our tasks. As we see, the ideal trend and the actual trend were very close to each other. We were actually on time based on the chart. In our last sprint, we added recycle location features, the map view for the recycle locations, the model confidence value, and the feature to automatically load locations based on the identified trash. In this sprint, Sprint 7, we were able to implement user profiling, improve user interface and experience, multiple entity recognition, and a fact and question screen. In this sprint, we implemented some feedback from our professor. We updated the architectural design to match a more generic format. We also added a sequence diagram. We improved our retrospective again to make the wording more simple and digestible. And for the demo, we put it in its own space. So now you can access it by clicking the project demo link in our GitHub. Now I hand it back over to Austin to talk about our backlog.
Hi guys, let me take you through the backlog of our Squander application. So let's visit the product backlog and the sprint backlog. And here we could see all the backlog stories that we had when we started the sprint 7. The SQD65 was his spillover from sprint 6, and the rest of them was specifically scheduled for sprint 7. Here you would also see stories for sprint 8, since it's a backlog, since it's a product backlog. And yeah, I have to apologize for my image being on top of some of the text, but I tried to remove it and couldn't fix it. So let's move on to the sprint back. So as you would see here, our backlog was scheduled for this week, and we had this month. We also had some extended holidays, uh, giving us another extra week to work on it. So we made sure all the stories that were signed for the sprint has been completed, and we also got a great opportunity to redesign the UI and UX, which should pay us back very well through the user experience. We also ensure that the stories that's specific to the users usability has also been completed. And so one of these features is to allow Mark to communicate with the recycling companies and providing enough information on their location so that he could get enough information to plan a trip to the location. Another high important task or story that we handled was to provide Mark with frequently asked questions so that he does not have to um, he had all the information he needed to answer his problems. Um, so taking you to the stories and acceptance criteria that we have stories from Mark and Simon, uh, which were on two different, I believe, three different pages. We had created an FAQ board for Mark, and we had to create Simon a profile creation page so that he could store the information that he acquired, so that when he comes back, he had everything that he needed to have. We also made sure that we follow the user stories format acceptable by the HR in the organization.
Hello everyone, it's me Akanksha again. Now I will be discussing about the test cases. So, as in this sprint, we have completed three user stories, and I will be discussing about the test cases for the user profiling user story. So, the user once the user opens the app, it should they should be able to locate the splash screen, and the expected result was user should be able to locate the splash screen, and the test result was user was able to locate the splash screen, and the test case is a pass. And then user should be able to locate the proceed button on the splash screen. The user was able to locate the proceed button and the splash screen, and also it was clickable. And again, this test case is a pass. Then user should be able to locate the login page once after they click the proceed button. So once the user was clicked on the proceed button, it was taking the user to the login page where New users as well as an existing users can log in, and this guest case wasn't passed again. Then locate for the sign up link. Users should be able to click on the sign up link and a new page should pop up where all the details can be entered. And the test results where the users were able to click on the sign up link and the new page did pop up and all the relevant data can be was be able to be entered by the user. And this test case is a pass too. Then the user should be able to locate the login button on the login page, and the user was able to locate the login button. And if all the correct information are entered into the page, and if the user click on the login button, it takes us to the new page, and this test case is a pass too. Then locate the sign up button. User was able to locate the sign up button when they clicked on registered as a new user. And the test result where once the user clicked on the registered as a new user link, and it takes to a new page where they could see the sign up button, and when all the relevant and data were entered and clear, the user were able to sign up, and this test case is a pass too. Locate the email and the password field. User should be able to locate the email and the password field on the login page. Once the user click on the login page, and there we can see the email on the login password field where there and it is a text field, and this test case is a pass again. Then we will be discussing the test case for the next user story, which was about the recycling details. So here, once the user locate the recycle location link, it should be clickable and the user should be able to see the link. And this test and the users were able to uh, see the recycle location link as it was able to click on the button and it will take them to the recycling location. And this test case was a pass too. Locate the recycling company. Users should be able to view the details of the recycling company, and once the user on the recycling page, and if the user clicks on any company, it will pop the details of the company where they will contain the address, the timings, the phone numbers, the representative name, etc. And this case is a pass too. Then we will be discussing about the third user story that we completed was the frequently asked question screen. Here, the user should be able to locate the frequently asked question link on the nav bar, and the user was able to locate the frequently asked question link in the nav bar, which is visible and clickable, and this test case is a pass too. Then users should be able to click the FNAQ link, and the FNAQ link was clickable and it opens up a new page, and this test case was a pass too. Then locate all the frequently asked question on the page, and the user was able to view all the frequently and most asked question on the page, and that will help user to get a resolution quickly, and this is a pass too. Now we will be discussing about the stories completed in this sprint 7. As you all know, in this sprint 7 we took 3 user stories, and all the 3 user stories were completed, and we did not had any spill over for the next sprint. This is how our burndown chart looks like. As you see, the total story point was 36, and we started the sprint from 3rd November and which ended on 30th November. And as we see that we were we were a little behind our deadlines, or we were a little behind the ideal trend, but we did catch up. In the start we were still catching up well, but in the middle we did found some issues, but we were again able to cope up in the end of our sprint. And as and due to that we did not had any spillover for the next sprint. And this is the complete committed versus completed ratio. So as you can see, from sprint 1 to sprint 4, our completed versus completed ratio was 100%. But in sprint 5 and sprint 6, due to some blockage and some issues, our committed versus completed ratios were not 100%. But again, in sprint 7, we have met our target well, and this time again, our committed versus completed ratio is 100%. And our average for all the 7 sprint is 98.12. And this is how our velocity report and the velocity graphs look like.
Hello everyone, my name is Rajat Nagakar and I will be talking about a retrospective. So in this time, in retrospective, we have what went well, what needs improvement, and future actions. This time, what went well was we had regular sprint meetings and had a better sprint estimation. The improvement needed was we have to estimate the buffer time and encourage more team involvement. And the future actions which we will be taking to overcome this will be estimate the buffer time into the sprint velocity and encourage team involvement by helping each other. The next is the future sprint. The future sprint is the sprint 8, which is the last sprint, and which has the user stories from the range from XQD65 to XQD108. The first user story states that working on deploying and building the AWS resource for Squander, whose priority is high. And the next one is XQD68, is which states that design and deploy AWS API endpoint, which we'll be using in the app to communicate with the model, whose priority is medium. And the next is XQD72, which states that as an engineer, John wants to schedule the pickup with the company so that he can be assured that his trash will be picked up, and its priority is high. The next is SQD74. As a retiree, David wants to know his recycling statistics so that he knows how much he has contribution to saving the world from global warming, and its priority is high. The next is SQD75, which is about optimizing Squander code, and its priority is low. Following it is XQD104, update GitHub and wiki page and technical paper, whose priority is medium. And the next is XQD105, create deliberate presentation, whose priority is medium. And the next is SQD106, create deliberate pre-recorded video and editing of it, which is priority is medium. And the next one is XQD107, which is update installation manual and user manual, and its priority is medium. So last one we have XQD108, that is test cases for sprint 8, and its priority is medium. So these are the user stories that we will be working in the last sprint, that is the sprint 8. Mm, Next, so next is the project demo. I'll walk you through the app screenshots which I have taken. So we have a login screen on the left and the sign up screen on the right. In the login screen for a registered user, it allows to log in with username and password. And if it is a new user, it allows to register via sign up with email, username, word type, and password. So in the sign up screen, as you can see, you can select the work type and sign up. So next is the reset password screen and a splash screen. If a user wants to reset his password, he can type email address, so that password reset link is sent to his registered email address. And on the right you can see a splash screen where a new user opens an app for the first time, user is navigated to the splash screen, and once a proceed button is clicked, user is navigated to the login screen. So the next is that we were able to recycle a particular atom, that is getting the name of the atom and the recycling locations. So this is a result screen on the left where where we can see the map view and the list view below it. So on the map view we see the list annotations of the recycling locations, and below the name of the recycling locations. So when we click on a particular recycling location, so we are navigated to the detail screen that we can see on the right, where we are able to see the address, contact, and the website of a particular recycling location. And the next is the profile screen. Once a user sign in an app, or sign up in an app, then a profile is created for him, and in the profile screen we can see its username, email address, work type, and address and contact info. And we have a functionality to also logging out the user um, and log in with the another user. On the right, you can see a FAQ screen which shows list of the frequently asked questions about how to use app. That is ranging from that is what are the common items that can be recycled, that we are able to recycle paper, plastic, glass, cans, cardboard, metal. So in such kind, it will give a basic idea about what a user how we can use the app, and what is the basic idea of about using this app. Next, the next is the API that we have used in the application, that is MapKit API and core location API. MapKit API we have used to integrate Apple Maps into the app, and to give a map view so that the annotations are the seen on the map. And the next is the core location API, which gives us users current location, mm, uh, and the coordinates. And now I will walk you through the GitHub link. So this is our GitHub link. So this is a Squander wiki page, and as you can see, the name of the project is Squander, and its project description below it. Below we have the team members, as Akansha Agarwal as a project manager, Austin Blaise as a cloud engineer, and Nicholas Wong as a machine learning engineer, and myself as an iOS developer, and Suryadeep Nalana as a full stack developer and a quality analyst. So these are the 5 team members, and below it we have a project design which we have shown the screenshots of our application, and some description below it. So next to it is the technology used. So we have used machine learning APIs such as Keras, Google Map API, MapKit API, and TensorFlow library, AWS Cloud Formation, and iOS App Development Toolkit. These are the technologies that we have used. And the next is the design architecture. The architecture consists of a view model architecture, and which is connected to the AWS cloud, and it also has a, code pipeline. So next is the machine learning architecture, which tells about us about how the model works, about recognition. The next below it we have Squander application artifacts, So here we have installation manual, user manual, and technical paper, both in the PDF and Word format. So last time it was CS691, and all the stuff regarding the CS691 are mentioned here. That is all four sprints, and for this. For this CS692, we have mm, all the deliverables listed in this format, that is on deliverable 5, deliverable 6, and deliverable 7. So each deliverable has presentation slides, and as a PowerPoint, as a PDF, and a technical paper with project demo. And also we have a sprint burden charts, and sprint completed ratio, and velocity charts. So at the last we have personas of the user who will be using the app, and finally we have the test cases and the Excel format. Thank you.